Good afternoon, everybody. Welcome to the welcome to Good afternoon, everybody. Welcome to the next session of the AICT Atal sponsored faculty development program. The title Innovative Micro and Nanotechnologies and Fundamental Principles, organized by the Department of Mechanical Engineering, Haldia Institute of Technology. So, first of all, let us welcome the dignitaries present on the dais. In charge IITC, Professor Devdatta Ghosh, Professor Tarun Kanti Jana, Dean of Engineering, Haldia Institute of Technology, Professor Gautam Kumar Ghosh, Head of the Department and Coordinator of Mechanical Engineering and Coordinator of this present Faculty Development Program. And last but not the least, Professor Subhash Bhumi, eminent speaker of today. So at this outset, I like to request Professor Jana to present a flower bouquet to Professor Bhumi. I would like to request Professor Gautam Kumar Ghosh to felicitate Professor Bhumi. So we are ready to begin another exciting session of talk. So let me brief the bio sketch of today's eminent speaker. Professor Subhash Bhumi did his Bachelor's of Engineering in Mechanical Engineering and Master's of Engineering in Production Engineering. He did his PhD in the area of robotics from Jadavpur University. Professor Bhumi is currently working as a Professor HAG in the Department of Aerospace Engineering, IIEST Shibpur, formerly B College. He is also former Dean Research and Consultancy, former Head School of Mechatronics and Robotics, former Head Department of Aerospace Engineering, IIST Shibpur. His research interest includes mechatronics, robotics, smart material, CAD/CAM industrial automation, assistive devices, innovative product development, BCI, HMI, and rural technology. Professor Bhumi is principal investigator of different sponsored projects, which includes Indo-US Embryonics, BRNS Spark, DST, AICT, UGC, Larsen & Toubro, Institute of Engineers, DST FIST, and MHRD National Institute on Design Innovation. He has published several research papers in prominent SCA journals and conferences and guided many PhD theses. He is a fellow of Institute of Engineers India, member of the Association of Machines and Mechanism, Robotic Society of India, and expert member of Rehabilitation Council of India. He was the Zonal Vice President of Association of Machines and Mechanism, editorial board member, and member of Robotic Society of India. Professor Bhumi is presently acting as Dean Planning and Development and President Institute of Institutions Innovation Council in IIEST Shibpur. With this short introduction, I'd like to invite Professor Bhumi for his lecture. My
মাইক লাগবে না ল্যাপটপটা লাগিয়ে দিতে হবে আচ্ছা আচ্ছা পাওয়ার ল্যাপটপ চার্জ নেই নাকি
না চার্জ আছে
তাহলে এখানে লাগিয়ে দিন
একটা হার্ড ডিস্ক আছে তো হার্ড ডিস্কটাকে যদি অ্যাক্সেস করতে হবে হার্ড ডিস্ক আমাদের জাস্ট একটা মানে এক্সটেনশন বক্স
এখানে গেলাম ওই টুলটা দিয়ে টুল 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 এখান থেকে নিয়ে কানেকশন হ্যাঁ 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 গুড গুড তাহলে এই জায়গাটা ব্লক হ্যাঁ ওটা চলো হবে না ল্যাবে কোথাও পোর্ট নেই হ্যাঁ ঠিক আছে না এই হাতে পাওয়া যাবে ফাইবার সাথে खुले আছে এইটা থাক স্যার এইটা থাক
So, good afternoon to all of you. Thanks to the organizers for giving me this opportunity to be present in this Atal FDP program. And this program, I came to know that this program is continuing for the last 10 days. So it's a 14 days programs, 2 weeks programs. And mainly it is concentrated on the macro and the nano systems. Okay. Now, as we work in the area of robotics and mechatronics, and there are words that like macro robotics, okay, macro mechatronics, and then afterwards it converted into micro robotics, micro mechatronics, and then nano robotics, nano mechatronics. Now, the audience may be a heterogeneous audience. So, before we go into the micro systems, especially the micro robotics and micro mechatronics part, let us introduce the topic of robotics and mechatronics to you. Okay. So, what is robotics? What is mechatronics? So, let us see few slides on this particular area, and then we will show you some systems which are called as robotics systems, which are called as mechatronic systems. Some examples we will treat, and after that I will go into the micro systems, micro robotics and micro mechatronic systems, so that this particular topic, okay, will create interest among you. So unless and until we know the macro systems, we will not be able to appreciate the microsystems. So that is the basic objective. Now maybe many of you have already came across this particular subjects, okay, which is called as robotics and mechatronics. So let me initiate the topic.
Slides ऊपर slides ऊपर
So the introduction is like that. If you see the basic, there are 4 circles appears. Okay, one circle is dealing with mechanics, the other is electronics, the third one is control systems, and the fourth one is the software engineering. So whenever we go into the subjects of mechatronics and robotics, practically speaking, we are taking the help of the knowledge of 4 different branches of engineering. So that's why whenever we go into the microsystems, micro robotics, micro mechatronic systems, this 4 branch of engineering knowledge will definitely come into the picture. Generally called that if you see this particular slides on mechatronics, okay, here we find that there are like imagine, initiate, innovate, invent, inspire, integrate. So we generally say that if anyone have this 6 I, possesses 6 I, quality of this 6 I, then he will be suitable, he or she will be suitable for the field of mechatronics and robotics. This is the initial means how this particular word mechatronics it has came into the market, and we see that this particular word mechatronics, it was coined by a Japanese company which is known as Ishikawa in the year of 1969, and they were given the trademark right of this particular word in the year of 1971. And this particular word of mechatronics, it consists of 2 words, two different words, mecha and tronics. Mecha is coming from mechanisms, which is part of mechanical field, and tronics is coming from the electronics. And then we find that this particular word, which was having a trademark right in the year of 1971, then this trademark right was abandoned in the year of 1982, so that the people can work in this particular area. So it becomes as a common word, so that there should not have any restrictions in using this particular concept or particular idea. This is a factory. And this factory is we call this as a mechatronics factory, where the mechatronics products are developed with the help of mechatronics products. So you are developing a mechatronics products with the help of the mechatronics systems. And this indicates the modern factory, shop floor, where there are CNC machines, conveyor belts, robotic systems, manufacturing process units, all are coupled together. And at the top floor, at the top, people are sitting in front of the computer and doing, basically they are doing the CAD/CAM related activity. Okay, so this is, we consider this as a future of the factory. These are the parts of the components which are the main components of mechatronics, And the mechatronic systems must have an operator, or it will have a computer network control. It should have a block of drivers. Drivers means is a power block. Okay, and there are mechanical devices. The mechanical devices is working in an environment, and all these components are connected with the sensor systems. So in general, in a short form, we can say that there is a communications, there is a control, there is a communications, there are mechanical items, processing equipments, processing items, there are actuators, and there are sensors. So all these constitute these mechatronic systems. Now this robotics, whenever we come into the robotics, also you will find that all these components are present in robotics. So generally we call that basically the robots is a subset of this mechatronics. Okay, so which is true for mechatronics, that is same thing is also true for the robotic systems. And whenever we go into the micro systems of mechatronics, micro robotic systems, the same concept will also persist. Now what are the examples of mechatronics products like? Okay, like the photocopying machines, video, camera units, then the fuel injection systems, micro pumps which is used for the medical treatment purposes, then anti-lock braking systems. These are all good examples of mechatronics products. All of you have seen a photocopying machine. So if you open the photocopying machines, you will find that thousands of mechanical parts are there, as well as there are thousands electronics and instrument related components are there. There is a software inside the systems which convert the colored picture into the black and white image. Okay, so say for example the electronic fuel injection systems. So these electronic fuel injection systems is basically used in all the modern car. Okay, so for their speed controls, velocity controls, this type of electronic fuel injection systems is there. We know that generally the modern car, they have such type of systems which the systems can understand that whether the vehicle is running through a congested road or this is an open road. Okay. So accordingly the fuel injections into the systems will be decided. So it is not the human, but it is basically the machines will take the decisions. Machine will take a decisions that how the fuel will be injected into the four-wheeler systems. Like say for example the micro pump. Okay. Generally what happens? Say 20 years back. Okay. In the medical field, in the medical treatment, when the doctor is supposed to give an injections to the patient, they have to inject say 10 ml of fluid. Okay. Medicine they have to inject into the patient's body within a fraction of a time period. So 10 ml of fluid is entered, medicine is entered into the patient body within a fraction of a second's time period. The effect is that sometimes the patients may not have patients may not be able to absorb that medicines. They may have some sort of allergy. So doctor does not understand, the doctor does not have the information that whether that medicine will be able to suit with the body of the patient or not. So at that time the doctors had the demand that the engineers should develop some kind of injection systems which will inject the medicines into the patient body for a duration of 24 hours time. So you can understand that the 10 ml of fluid is injected into the patient's body for a duration of 24-hour time. So very small amount of dose will be entered into the patient body. So it is a kind of injection systems. Okay. So there is a piston cylinders arrangement is there, like a common type of. But the movement of the piston inside the cylinder is so slow. It is not like a stop. It is so slowly it is moving that all the time injected. Medicine is injected. But the amount of injections of the medicines into the patient body is so small that any reaction will take place with the patients. Because by that time when the medicine is slowly injected into the patient body, the patient has developed some sort of resistance against that particular medicines. So no harm will take place, at least from the point of view of the allergy point of view. So these are the requirements, means the doctors require this kind of devices, this kind of instruments, okay, from the engineers. So 20 years back it was not there, but now you will find that all the hospitals, they have this kind of systems, injection systems, where the medicine will be injected in the patient body okay, 10 ml of fluid or 15 ml or 20 ml of fluid is injected for a duration of 24 hours. So now let us go into the robotics part. Okay. You can see that I have already mentioned that robot is basically it is a subset of mechatronics. So whatever the qualities or the physical characteristics the mechatronic systems will have, the same kind of characteristics you will find in the robotic systems. Now robot, if you consider a robot, robot is basically we generally understand that in a layman language we understand that it is a kind of machines which looks like a human and which works like a human. Okay, so that kind of systems is generally called as a robot. So robot is not a human type. Okay, and the characteristics of the robot maybe seems to be like a human because the human has created these machines. And whenever we have created, we try to give the look of the machines or the performance of the machines similar to the human is like. So that's why we generally call that robot is basically a human, artificial kind of machines which looks like a human or which works like a human. But if we see the industrial definitions of a robot is basically a reprogrammable, multifunctional manipulator designed to move the parts, material, tools or specialized devices through variable program motion for the performance of a variety of tasks. So whatever the definition has been provided over here, this is a kind of industrial definitions. How the industry people, we know that the robots are nowadays is used in the industry. Okay, Maruti is using for the development for the manufacturing of the vehicles, even for the painting of the vehicles they are using the robots. Okay. So the companies means all the automation companies, automated companies or automation related companies, they have robots installed in their in the shop floor. So robots are using basically they are used as a machines and sometimes they are considered as a replacement of the humans. So instead of doing some task by the human, we are employing a robot to do the task. So from that perspective, the definitions is true. It is a reprogrammable manipulator. Manipulator means which can manipulate. Like I can manipulate my hand. Okay. So I can manipulate my leg. Whenever I am moving, basically I am manipulating my leg motions. So it is a kind of reprogrammables. It is a machines which is computer controlled. Okay. So the like or maybe most of you have some sort of exposure or experience with the CNC machines. So for the operation of the CNC machine, you have to write the code. So similarly, in that form, for your operations of the robot also, you have to write some sort of code. And this code, you can change it. Okay. And mainly, this kind of robots or the machines are used for the material handling purposes. So it will move to one locations, pick up some objects and then place it in some other locations. So that is the main purpose or the objective of a robots systems. And there are different types of robots are there. Okay. Like from the figure you can see that one kind of robots looks like a machines and this is the machines which is this is a robotic system, industrial. We call this as an industrial robot which is used in industry for doing some sort of pick and place type of operations, material handling operations. Conveyor belts are there. In a factory also, the factory also uses the conveyor belt. But whenever we are using the conveyor belt, the path of motion of the material from one location to the another location is basically fixed. It moves along a fixed line, or maybe it is maybe of a circular line also. But that circular portion is basically a fixed one. But whenever you think that I will pick up the object from here, I will place it over here in one time. The next time I will pick up from here, I will place it in some other locations. This is not possible using the conveyor belt systems. So these robots are used for the industries for the material handling purposes. Also, the robots can also be used for amusement purposes, entertainment purposes. So you can find out like this is a dog, robotic dog. Okay, you can play with this robotic dog also. if you see the industrial robots, means this is an industrial model of a robot systems. Okay, this is not looks like a human being. It looks like a machine, right? So this part is basically this known as a manipulator part. Okay, and this part generally what happens here, you can I think you have a good knowledge of understanding of mechanical engineering. So these are known as the joints. This is known as one joint, this is another joint, this is another joint. Like we have a different joints over here. So this portion, you can consider this as a manipulator. So I can manipulate it because I have joints over here, I have joints over here, I have joints over here. So that's why I can also move, I can rotate. Okay, so I can do these motions, I can do these motions like that because I have the joints placed over here. And this part is known as a mechanical manipulator motions. Now the middle portion is known as a controller units. It's a control portions. Okay. Now all these are driven either by the servo motors or they are driven by the stepper motors. So like here in our case we have a muscles. So because of the muscles, movement of the muscle, extension and the contraction of the muscle, we have this kind of motions. But in case of a robotic system, it does not have the muscles, but they have a actuator units. And these actuator units includes like a motor. It has a motor over here, and these motors maybe I think those are from the electrical or instrumentation background. They know about the stepper motor. It can be a stepper motor. It can be a servo motors, or it can be a DC motors. Okay, so any kind of actuator units you can use. Even instead of the motor, electrical motor, we can have a mechanical motors, and the mechanical motor is basically the pneumatic cylinders, the hydraulic cylinders, they are known as the mechanical motors. So either you can have an electrical motor systems here or it is driven by the mechanical hydraulic actuators or the pneumatic actuators, pneumatic pistons, hydraulic pistons. So they can be accommodated over here. Now for control of this actuator units, we require a controller units, and this controller unit is basically an electrical part. This is an electrical part. Okay. So all the electronics and the electrical components, they have been placed over here. Now without this electrical or electronics control box, you cannot operate these particular machines. You cannot operate. Now side of you can see that there is a pendant. This is known as a teach pendant. And this teach pendant is basically a kind of remote. So for operations of a TV, okay, we require a remote. So similarly, for operations of this manipulator unit, we require a remote. So this is known as a teach pendant. And then the fourth one is basically a computer. So it means that you can operate the machines with the help of this teach pendant, handheld type of teach pendant, or you can write some sort of code of the program in a computer, and then you can connect your systems with the computer. These systems will be connected, and then you can operate this. Okay. Now the question is where we are, when we should use the robots. Now here you can see that there are 3 D's are there. One D stands for dirty, dull, and the dangerous. So when the situation is dirty, you replace the human by a robot. When the work is dull means, say for example, if somebody asks me that you do the pick and place operations for 8 hours per day, 365 per year, it is not possible. As a human, it is not possible. So this is a very dull type of work, monotonous kind of work. I have to do this kind of work each and every day. It's a very monotonous kind of work. So if the work is a monotonous work, you replace the human with the help of the robot. So the situation with this, when the situation are dull. And the other one is dangerous. When the situation is dangerous, say for examples, we have radioactive environment, okay, or radioactive power plant. So there you cannot send a person because the environment is radioactive. Okay. So in that situation, if you have to do certain work, you replace the human with the help of the robot. So you send the robot for doing certain activity over there to do certain tasks. So don't send any human when the situation is dangerous. Say for example, there is a earthquake, there is a collapse of a building. Somebody may have trapped inside the collapse, inside the debris. Then what you can do? You can check whether any person is alive, he or she is alive, under this debris or not. But there, the most perfect situation is send a robot over there. Send a robot. Robot will move here and there. It will enter into the debris and it will find out that whether the person is still he or she is living over there. This kind of task can be performed better by a robot rather than a human. Okay. So these are the philosophy of 3D philosophy: dirty, dangerous, and the dull. When these situations will occur, then you can apply robotic systems. So with this basic introductions of this mechatronics and robotics, let us now just to name this. This is a rope, industrial rope. We have it in our laboratory. Okay. So you can see that it has an arms, okay, and it is moving from one location to the other locations. The motion is so fast, and it has been programmed to move with the speed of only this is of the 5% speed of its maximum. So you can understand that whenever it will move with its 100% speed, how quickly it can move from one location to the another locations. This is known as a KUKA robot, which is a German make robots. Okay, and this robot we have installed it a few years back, and it has a capability to handle 5 kg load. That means it can pick up a 5 kg load, maximum 5 kg load, and it can move with the load of 5 kg load. I am showing you a gantry type of robotic systems, but this is a gantry type robots. Robots looks like it has a different looks like, okay. Now gantry type means it moves along x-axis, it moves along y-axis, it moves along z-axis. So there are 3 axes are there, x, y and z. So you have developed a robot which can move along x-axis, y-axis and z-axis. So it is a work like there are three pieces are there, cubes are there. One is a cube, b cube and c cube. You have to arrange it. First is A, then B, then C. Or maybe the C at the bottom, then C, then B, then A. Or maybe A at the bottom and C at the middle and the B at the top. You can decide. So it is a kind of assembly kind of work. Now I am showing this. This is basically a simulation. This is not actual. This is a computer simulations. Okay. The previous one was the actual one. Now here the understanding is that the actual robot is cost very high. Okay, so the previous robot system that we have shown to you is very costly systems, and sometimes it may not be possible for an academic institute to invest that much of money only for the training purposes. So what we prefer that we can give you a knowledge of the robotic systems with the help of simulation kind of work. So this is a kind of simulation kind of work. This is another one. This is a pick and place type of operation, simple robot. Okay, and even the students can also build up this kind of robotic systems. Okay, and here the purpose of this robot is to pick up the object from one location and place it to some other locations. I am showing you the open structure of these robotic systems. So open structure of the robotic systems, you can consider that there are so many mechanical parts are there. Then there are small electrical motors are there. Then there are like electrical wires are there. And also it contains the microprocessor units, which is known as a controller unit for this case. So the control systems, the actuator systems, it has also a number of sensors and the mechanical parts. As a whole, it constitutes the robotic systems. This is I'm just showing you some examples of robotic systems and mechatronic systems, okay, that has been developed by the undergraduate or postgraduate or PhD students of our department. Okay, I'm just sharing with you some of the product that has been built up. So this is our laboratory where the students was involved in development of a beam, which is known as an yellow beam. Like, okay, all of you are now interested for quadcopter kind of systems. Okay, students are working with the quadcopter. Industry is also looking for the quadcopters for different purposes. The defense people also, they are working with the quadcopters for defense purposes, surveillance purposes. Now this is a kind of quadcopter that has been is a quadcopter. It's not a quadcopter. We generally call this as a blimp. Is an air-filled type of balloon type. Okay, and this balloon, it can fly at a higher range. It can fly, and it has some sort of camera inside it. So whenever it is flying, so at that time from the bottom it can pick up the take the pictures or the video from the bottoms, and then it process it, and then it can find out the necessary instructions, the necessary informations. So the purpose of this kind of balloon is, basically the objective of this kind of balloon is that it should, this is a kind of balloon, okay. Now students has developed this balloon, and the design was not proper, so that's why we could not make it to fly like, okay. So its back side was heavier than the front side, so dynamically it was not a balance. So I'm just showing this one. This is basically a failure, case of failure. Student failed to deliver the product like, okay. But the thing is that the student then, after this trial, we found that a lot of problems are there. Maybe some design related issues are there, okay, which we could not identify before we have developed these systems. But during the experimentation, we found a lot of problems are there. Systems has a lot of problems. So we studied these problems, and we tried to find out that where from these problems are coming, like why it is not flying, okay. Then we found that we made some sort of mistake in the design, and then after that we made the calculation again, and then we again manufactured this blimp, this balloon, and then we tried to make it fly, and then we found that success. So basically it is a success story of the student side, but before the success there was also a story, failure story behind it. This is a third word, that means when it is flying, basically its objective is that that it should fly, okay, the locations, and whenever it is flying, it should capture the video of the back of the bottom, and then it will process this video, and from there necessary informations will be extracted. Now earlier it was decided, means this kind of balloons, it may find its applications for the surveillance purposes, okay, like a security purposes, surveillance purposes. Maybe that our country's border may have this kind of balloons at some strategic locations, maybe in the northeast side, maybe on the northern side, maybe of the western, eastern side, anywhere. If you want that some sort of surveillance is required along the India border, so you can place this kind of balloon over that border. So whenever it will fly, it will take the pictures, images, and then process, and then it can find out, say for example, somebody is trying to enter into the India border. Immediately that through the video, you will be able to capture the information that somebody is trying to enter into the India border, like. And then when it is detected, immediately you can take also the decisions, okay, or you can take the necessary actions that how this entry may be stopped. This part is known as the electronics part. It contains all the electronics part, and this is known as a gondola. This bottom portion is known as a gondola, which contains all the electronics part which is required for making it fly. Okay, and it has a contact with the operator. That means there is a person who is basically controlling the movement of the blimps. Okay, so remotely you can control the movement of the blimp. And you can see that this is an experimentation purposes, so that's why there is a tether. It is a tether. Okay. So if any accident takes place, then what will happen? If any accident takes place, then the blimp will be out of control, out of your control. Okay. So if the electronics, say for example, the electronics failed. Okay. And this balloon is basically moved. There is a propeller in it. You can see that the propellers, they are rotating at a very high speed. So, say for example, the battery power is exhausted, okay, so you will not have any control over it. So, as this is a training, means trial purposes, so that's why we have a tether. So, if anything happens wrong, at least you will be able to bring back the blimp as it is a tether. We have heard about surgery. Okay, doctor do the surgery operations, and there is a word like a telemedicine. All of you know about this telemedicine, and also you have heard about this one word like a telesurgery. Doctor do the surgery operations in a telemode, like. Okay, so the thing is that sometimes it may happen that there is a doctor, very senior doctors or very specialized doctor. He is sitting in Bombay. Okay. And the patient is lying in Calcutta hospital, since some of the hospital in Calcutta, and there is an emergency operation has to be performed. The doctor will not be able to fly, or the doctor will not be able to come in Calcutta. So in that situation, how you will take the help of the doctor who is very expert of that particular surgery type of operations. So from that concept, the telesurgery came into the market, like. Okay. So in this process, what happens? The doctor may be sitting in Bombay, Calcutta, Delhi, Bombay, London, anywhere the doctor may be, and the patient may also be anywhere in the world, like. But they will have the connections. They will have a connections. So that means the operation theatre, whatever the operation has to be performed in the operation theatre, that is basically controlled by the doctor who is sitting at the remote locations, far away places. Only thing is that both the surgery room and the doctor should have an internet connections. Now this is a device. This is a device which is known as a haptic device. Okay, it's a kind of haptic device. It is similar to the joysticks, which is used basically for the playing of the game. We play the games with the help of the joysticks. Okay, so similar to that. Holding this handle, you can move these arms, these arms, these arms. This looks like a robot type. This is not a robot, but looks like a robotic systems. And holding this arm, you can move it. Now you can see that whenever you are holding the and you are trying to move it, you see that you are basically, this system is connected with the robotic systems. So this is a robotic arm. You may consider that the doctor will have this haptic device at his end, and this robot is basically located in the surgery room. So that this robot will do the surgery, the black one will do the surgery operations, and the doctor is giving the instructions from his or her place, from a far away places, with the help of the joysticks. Okay, so you can see that how the coordination is taking place. This is known as a right hand left hand configurations robotic systems. One hand is the right hand, another hand is the left hand. Okay, and some of the work is there which we can perform with our own hand, means with a single hand. So I can pick up the object from one location to the another locations, I can place it. But there are certain actions are there which require both hands. Say for the nut bolt tightening, can you do it with a single hand? You can't do it with a single hand. You require the both hand operations. Nut and bolt tightening, you require the both hand operations. So here, this activity is, these two are considered as a twin robot. That looks like a twin type. Okay. So one is right hand, another is left hand. So both the right hand and the left hand you can control it with the help of the joysticks, with the help of the haptic device. See that a person is sitting, standing at one locations, and there are two robots in some other locations. Okay. So here the objective is that whether you can give the necessary instruction these two robots without touching these robots, without direct contact with the robots. Can you give the instructions? So that if I say, for example, if I move my right hand, the robot in the left hand side, it will act. How this is possible? Without touching. You are not touching any of the robots, you are not touching. You just moving your hands. Moving your hands.
Is it by robot vision?
This is by robot vision. So there is a camera in front of the person. Okay. And this camera is always, it is taking the image. Continuously it is grabbing the image, and it is processing the movement of the body parts, hand movements, leg movements. Okay, so from the image it is possible to find out that whether there is any movement of my hand or not. So if, for example, if I do like this, and if my video is captured, and then after the video is processed properly, if you process it, from there you can find out what is the joint angle here, what is the joint angle here. So that information we can capture, we can find out through the image processing technique. And once you found out the image processing technique, through the image processing technique, that what is the joint angle, then this instruction, this joint angle movement instruction is fed into the robot. The program is written in such a way, and then that particular joint will move. So here you can see that though the human is not touching the robot, but still he is able to control the movement of the robot. Okay, so maybe in a day will come when an operator can control the machines. So when the operator will move in a factory, okay, if some machine, say for example, this machine is stopped, it's not running, the operator may do like this, machine will automatically start its operations. So this is known as a man-machine interface. This is a robotic system. Okay. Now this robotic system, you can see the size of this system. Previously, whatever the size I have shown is quite a big size machine. Okay. So that was a big size machine. Now you can see, look into that parts, components, its size has been reduced. Okay. So size is still, it is in the macro range, means in the bigger size, but still whatever the macro size we have shown you earlier, compared to that, it is like a mini size. Okay. Now what this is this you can see that basically this is like a few modules are there, 4 modules are there. One module is connected with the another modules, and this module is basically guiding a path. Okay. Now you just consider that sometimes what happens in case of a nuclear power plants, there are tubes are there, and these tubes are like a bent tubes, and these tubes contain some sort of radioactive material, and they require some sort of periodic maintenance. Okay, maybe the cleaning or maintenance of the tube or the inspection of the inside of the tube is required from the safety perspective. Okay. Now the question is that how you will do the inspections of this type of tubes, because you cannot send a robot for doing these operations. Okay, the size of the robot is quite big. How it will enter inside the tube and it will do the inspection task. So there you require some kind of machines whose size is very small size, because the diameter of the tube is very small. So we targeted that whether it is possible to make some sort of electromechanical systems or electromechanical devices or a mini size of robotic systems which can enter inside the glass tube and it can move from one location to the another location. So that was our target objective. Okay. And then towards that we found that this maybe is a kind of you can say this is a kind of artwork. All of you have seen an artwork. Okay. So the movement of this kind of device, robotics device, is basically mimicking the movement of an artwork. Okay. So whenever we go into the robotics, basically through the robotics we are trying to mimic the natures. So in nature there are many systems are there. The robotics engineer is trying to mimic that kind of systems, that kind of devices. And one of the creatures in the universe is like a artwork. Okay. And we are trying over here that whether it is possible to make some sort of machines which looks like an artwork. And it falls under this mini robotic systems. So this is like a tube. This is a bent tube, real bent tube. Okay. And this is, if the bent tube is like this, so how you will send a robotic system inside this bent tube? Next to impossible. So you have to think about certain creatures. There are creatures there which can enter into the one side of this bent tube and it can come out from the other side of the bent tubes after some time period. So you have to develop, you have to mimic the motions of that kind of creatures. This is a student made project. So the students, they develop a robotic kind of device, okay, for pick and place type of operation. And you can see that this robot is moving from one location and then picking up the nail, okay, which has been placed in some other locations and then drop it to some other locations. Now the beauty of the system is that this movement of these robot systems is not following any kinematics rules, like, okay, those who have studied about this robotics, you know that there are the forward kinematics and inverse kinematics are there. So it is not following any kinematics. The simple thing is that we have included artificial intelligence or the neural network kind of knowledge for moving the robots from one location to the another locations. Okay, so here you can see that the knowledge of the computer science is used for movement of a electromechanical devices, so that this kind of systems must move from one location to the another locations in an intelligent way. These are another systems, okay, and if you have studied robotics, then in robotics generally we call the robots are of serial type of robots, okay. So there are another kind of robots, whatever the robots I have shown to you, these are all serial kind of robots. Structure is one end is fixed, the other end is free. Like in my case, okay, I can consider it as a serial robots where one end of my movement is fixed, legs are fixed for the base, and the other end is free. Means my hands portions, this is known as the gripper portion, this is the free portions. But there are another kind of robots are there, which is known as the parallel robot. I will show you an example of a parallel robot, then it will be clear to you. The third one is known as a continuum robot, and this is the new additions of the robotic systems. Okay, like say for example, something has entered into this in your maybe the air passes. Something happens wrong, and some extra or some foreign particle has entered into your duct. How we will bring it from that locations? Okay, this is a very challenging one, because our duct, okay, from the mouth to the entered into the bronchial site, okay, the duct is very narrow and its path is not like a straightforward path. It is like a zigzag type of paths are things. Okay. Now, say for example, the doctors are interested that develop some engineering device which can be entered inside the duct, and it can bring out the foreign particles from the air duct or maybe the food duct, whatever may be. Okay. So from that, for that, this systems is known as a continuum type of continuum systems. Let us play this one. Here it is shown that wherever the blue object is placed, okay, the continuum robot is moving towards that directions. All of you have seen the elephant trunk. You have seen the elephant trunk. Sometimes the elephant trunk is straight, sometimes it is bent, sometimes it is like this. It can change, so flexible it is. Okay, how to make it? If you consider it as our hand, it is not that much of flexible. I cannot move it like this way, that way. I cannot do it. It has a lot of limitations it has. But when there is a requirement that, say for example, there is some object is placed in some corner, okay, in a straightforward way you cannot bring that one. Then how you will bring it? I will move my hand in this way, then that way. If possible, again, if I can take a turn, then I can reach to that particular spot. But in most of the cases, our hand systems has a limitations, flexibility limitations. So in that case, if you have this kind of continuum structures, continuum systems, okay, then you can move it very easily. You can move from one location to the another locations. So it is basically the 2D plane. On a 2D plane, you have some sort of curved structures, and this curved structure you can have different shape. Sometimes it's maybe like a S type structures. Sometimes it's maybe like a I type of structure. Sometimes maybe it may have some sort of U type of structures. So you can change, you can vary your shape if you are using a continuum type of systems. So this is similar to, you just consider this as a similar to the elephant trunk. So wherever the blue colored object is moving, you can see that it can track the blue colored object. How it is possible? Again the same thing. There is a camera at the top, okay, and wherever the blue colored object is placed, it is basically under the purview of this camera. So the camera is taking the image, If you process the image, you can find out where the blue color object is located. XY location of the blue color object from the image it is possible to find out. And then you have written a code for the control movement of the continuum type. So you are just asking the continuum to move to a location x equal to 100, y equal to 200. That locations. Then it knows that how it will have to bend its structures. That is the inside computations it is doing. Okay, some mathematics, complicated mathematics is involved. And through that, it is able to find out that how it should turn itself so that ultimately it will be reached to the destination location where the object is placed.
If there are multiple blue colored objects.
Multiple objects. Now, multiple blue color objects, you must, but if there are also two blue color objects are there, then also, like a human also, we don't know unless and until we have some logic. So, if you say that which one is nearest to you from the present location, maybe it will go to that location first and then it will move to the second location. Otherwise, it will becomes like a puzzle, okay, and it will stop at that locations.
Here in this experiment, how it is programmed?
How it is?
Programmed by using artificial intelligence.
Any other color?
Color you can means instead of the blue color, if you have a red color one, then again you have to change some sort of code in the image processing logic. Okay, what is the RGB values like that? Which is your target one. Even if you keep some sort of white colored object, maybe this continuum will not move to the white colored object unless and until you have taught it to move to that particular objects or targeted objects. I'm just moving at a faster speed. That has been shown. Now you can see that this is the duct. Okay, one for the foot pipe, another is for the ear duct. So there are two ducts are there. Okay. Now here, say for example, you have to move the object towards these directions. Unless and until it is actually controlled, properly it is controlled, then this may move towards the bottom one. And if it moves towards the bottom one, then maybe your purpose of experimentations will not be fulfilled. So when the duct is like this kind of duct, where there is a bifurcation is there, possibilities of moving either to this one or that one, then in this kind of situations, okay, it is very important that how you are controlling your continuum systems, okay, so that it should move towards the bottom one, to the bottom one, not to the top one, or to the top one, not to the bottom one. So with little bit of idea about this macro systems, okay, robotics macro systems. Now we move towards the micro systems and the nano systems. Now, as the name suggests, the micro and the nano systems, it indicates that the dimensions of these robots should be small one. Okay. Now, probably all of you know that there are certain kind of medicines has been developed, okay, by the doctors and the engineers in a combined way, that there will be a device which will be put inside the human body, and whenever, say for example, the sugar percentage of sugar has been increased, value has been increased in the blood, then immediately from that device, okay, some medicine will come out, automatically it will come out, and it will mix up with the blood, and your sugar will be under control. Like we heard about all these kind of medicines, okay, which is basically an engineered medicines. Medicines has been developed with the combined effort of the doctors and the engineers. Now, for these devices is very small. If it is a millimeter range, we can see, but sometimes the size of the object is so small, even you cannot see through your eyes also. You will not be able to detect it. Like the bacteria, we cannot see like, okay. But there are instruments and devices are there which can figure out that whether there is any bacteria at that location or not. But through our eyes, it is not possible to detect it. So, here we are moving. Basically, if you see the advancements of robotics, we are basically moving from the meter range to the millimeter range to the micron range and to the nano range. Okay, people are working like that. Now there is a demand from the country, means defense side. Some of the countries, they are looking for the robots which you will not be able to detect it through your eyes. Will not be able to detect it. Say for example, there will be a robot in this room, okay, and it will capture all the discussion that is taking place in this room. It will also have spy systems, and this information it will send it to the control station. So the person, those who are sitting at the control station, they can hear what we are discussing over here, and they can also see us. So this is the demand from the, means for the surveillance purposes or for the security purposes. Countries are working in these directions. So these robots, even if there is a robot over here, you will think that this is a very small dust particles maybe. You will think like that. And we heard that, and also it is true that these kind of devices are used in the battlefield. Say there are two countries involved in the battle, okay, and you want to get some sort of information from the opponent side, what the opponent people are discussing, what is their strategy. So what you can do, you can send this smart type of micro robot where the opponent soldiers are staying. It will be over there and it will capture all the informations, sound and video. It will take it and then it will send it these informations to the control station, and its journey will be like a mission, will be like a, say for example, its mission will be like a 1 hour mission. After 1 hour, this machine will die automatically. It will die automatically. At that location, it will die. Okay. Because these systems are very small systems, and for the operation of the system, we require some sort of external power, some kind of battery power. And the size, you can imagine the size of the battery. You can imagine the size of the battery is so small that it can have only the power for maybe for few minutes. It may not be even for the hour also. After that, automatically the system will have a self-die. Okay, they themselves will decide that when they will die, and then they will die. So this falls under the category of microsystems and the nanosystems. So this is a field of technology that develops robots at a micro scale, extend the human capabilities, new and revolutionary tools. Experimental micro robot size scale is of the order of centimeters to millimeters. Perform a specific task repeatedly and with precision. So these are the basically the definitions of the micro robots part. I am not going through the definition part of it. Now this, you can see that the miniaturization increases the payload volume to power capability significantly. Main rationale for pursuing the extreme miniaturizations. So the question is that why we should go for the miniaturizations. Okay. So there are certain activities that there which will not be performed by the macro systems. Like say for examples we are saying that we require a robot which can enter into the debris. Now the thing may be that inside the debris the human cannot enter. So we are looking for the robots which is very small size, which can enter inside the debris. It can move from here and there inside it. It can move far off places, and it can detect the informations of life. If anybody is having the life over there trapped inside it, and then give the informations to the alarm to the control station that it found the existence of life in some bodies. So for that purposes, this is a real requirement. This is a real challenge how to find out. Like collection of data, collection of information, spy activity. You require a robot. You require machines, because if you send a person, the person will be trapped immediately. But if you send a small robot, nobody will be able to detect it. We are talking about this with surface robots, surface micro robots, which moves over the surface. But there is a requirement also the robots, flying robots, small size robot, flying robots. Okay. So, so what we can see that sometimes you have already seen that sometimes we find in the sky there are birds are there. So along with the bird, there is something different. Okay, looks like a different type. Birds are there. That bird is basically an artificial bird. That means somebody has made a machine or an equipment or a flying device which looks like a bird, but this is not actually bird. And this bird has been mixed with the other birds in such a way that you will not be able to identify that whether it is a real bird or it is an artificial bird. And this may fly inside the region of the opponent's regions. Okay. So you can send some sort of flying bird inside the opponent's region and you can collect some information from there. And these are all spine type of flying devices. We call these as a flying robots. So you can see over here, this is one of the flying robots. And if it is a fly, you will not be able to detect it. It looks like some insect is flying like. But this is an artificial robot. So what is the technology? Because the conventional technology will not work. Conventional technology is basically, say for example, all the previous robots, they were made of metal pieces or sometimes it may be made of a plastic pieces, which is very heavy. So you cannot make this system as a heavy. If you make it heavy, then it will find its difficulty in flying. And also at that time, for make it fly, you require a high-powered power source. A high-powered power source means the size of the power source will be increased. So size of the total system will also increase. And if you make a bigger systems, people will be able to very easily they can identify that this is a flying robot. So from all restrictions, from all sides, these are the different restrictions has been put into the micro robot systems. Now, if you see the macro size, macro is generally it is of 10 millimeter size. This is known as a macro size. This is normally it is observable, means that is visible there. But if it is a milli size is 1 millimeter of the range of 1 millimeter range. This is also visible. And whenever we are talking about this micro size, then the size of the minimum dimension is of the order of 1 micrometer, and which is basically invisible to the eyes, but it is visible under this optical microscope. And whenever you are talking about this nano size robots, nano robots, its dimension is of the order of 1 nanometer. Dimension is 1 nanometer. And this is, practically speaking, this is not visible, not through the eyes, or even it is not visible under this optical microscope. Only it is visible upon the scanning type of microscopes. So scanning microscope, electron scanning microscope, these are very costly systems, they are very high powerful systems. Only if you look into this kind of systems, nano robots under this scanning microscope, then only you will be able to find out that something is there under this scanning microscope. So you can imagine that the people are working in the form of nano size. They are trying to develop a particle, they are trying to develop a robotic systems. Whatever I have shown over here, so that kind of robotic system, they will try to make it in the form of a nano type of systems. Really it is a challenge. What type of actuator you will get? Will you use some sort of RC motor, remote control motor, which is used in the aircraft, or it may be used for the making the model, robotic model system. The students generally they use it. But the size of this motor is like this. So you cannot use this kind of motor. So what should be the motor? What should be the sensor used? What should be the actuator used? Which controller you have to use it? What will be the programs inside the controller? This is a really a challenging bit. This is a small robots. You can see that but this is a micro scale size of robots, and the size of the robot is basically the size of the coin. So you can see that there is a bottom, at the bottom there is a coin. Coin is there, okay, and on the top of it, this robot has been placed. This robot has been placed. So you can imagine the size of this robot, so small. Though it is visible, but the size is so small. So this particular slide indicates the applications of robots, practically speaking, micro robots, applications of micro robots for the biomedical purposes. The purpose is biomedical, but the health, related to the health. And this is the requirement of the doctor's side. Doctors are pushing the engineers in a challenging mode. They are throwing the challenges. Because there are certain treatments are required, and there are certain treatments the doctor wants to do. For doing that type of treatment, you require tools, and the size of the tools should be of nano size or micron size of tools. So the doctors, they will use it only when the engineers will be able to produce that kind of tools. So it is a really challenge. And in most of the cases that the engineers have accepted this challenge and they have delivered the product. Like some sort of optical surgery. They require small robots. Optical surgery purposes. And you can see that there are other systems are there, like say for marking. Say for marking. So the marking is basically, the marking, it indicates that the doctor wants to send some foreign particles inside the body, okay, to locate some objects, location of the object. Say for example, some cell is maybe damaged, okay. Doctor wants to identify that particular cell. Doctor wants to identify that particular cell. And most of the cases, all of you heard it, all of you know that in case of a cancer, treatment of the cancers, generally the doctors are unable to detect the cancerous cell. Okay. Or sometimes whenever we are putting the medicine in a cancer patient, okay, the medicine will not only act on the bad cell, but sometimes they also work on the good cell also, on the periphery of the damaged cell. So the doctor has a target to damage a particular cell, which is a cancerous cell. But whenever they are targeting it, as they are unable to target it properly, so sometimes they also miss the target, and they also, what they do, generally they also damage some real life cells or good cells, they damage it. So for treatment purposes also the doctor wants to identify the bad cell very precisely, and for that purposes the doctor wants to send some sort of tools inside it, and these tools will be like a robot. This will be entered, say for example, maybe it will be entered into vein or something, and then it will be guided. This robot will be guided inside our body, and through the guidance it will be moved to that particular locations where there is a damage. So you can understand that you are controlling the movement of a foreign object which has been entered inside our body externally. From externally you want to control it. And sometimes maybe electromagnetic waves, okay, electromagnetic systems, or maybe some other kind of energy will be used for moving this particle from one location to the another locations. Say for example, there are two particles are here, okay. So if you use some sort of magnet, if you control the property of the magnet, the strength of the magnet, okay, by controlling the strength of the magnet, what you can do? You can either push these ferromagnetic materials away from the magnet, or you can attract the ferromagnetic materials towards the magnet. So the motion, you can control the movement of the motions of this ferromagnetic material. So similar to that, in this micro and the nano robotic systems, engineers are trying to make some sort of nano robots, and these robots will be controlled, its motion will be controlled externally. So some sort of magnetic field, electromagnetic field, or maybe some kind of electrostatic field will be developed, which will control this movement of these foreign particles, and then it will be guided in such a way that ultimately it reach to the target location. So that is known as a known as a marking systems. Okay. So for these purposes, it can be used. The other one is very common, is the drug delivery systems. The robot will contain all the drugs. Okay, I have mentioned that maybe the sugar treatment purposes. Okay, so this drug will, this robot, this micro robot, it will have the drug inside it, and whenever it will be required, drug part will come out from this capsule robot, and it will mix with the blood, and your sugar will be under control. And people want that kind of devices like that. And once a drug is injected into your body, means fitted into your body, is the other kind of medicine that has to be injected. Or maybe this drug is sufficient for next 5 years. After 5 years, you have to bring out the drug part from your body and insert again another new drug capsule you entered it. It will also last for the next 5 years. So the patients, means the demand is like this, our demand is like this. I don't want to take the insulin each and every day. Okay, it will be automatically detected by my body. I don't want to take the insulin each and every day before this food or after this food, whatever maybe, I don't want to take it. Whenever there is requirement will be there, body requirement will be there, this insulin will be come out from these micro robots, it will mix up with the blood and my sugar will be under control. And this is not story like. Already the doctors and the engineers, they have already developed such kind of systems. Maybe these systems are very costly from the Indian perspective, but it is there, it is a tested one. You can see this is the micro robots, these two robots are there. Okay. It's like a two robots, and you can see that it has been placed on the hand's palm, and what is its size like? The size of the palm and size of the robots. So small. And there are certain tasks are there, like this is another robot which is inside your palm like. So small in size. Like these are the robots, like small robots are there. Okay, and these robots are doing some cooperative activity. Previously, I have not used this term of cooperative. Okay, so when so many robots are there, like here, so many people are sitting over here. So if you want to communicate with each others, you can communicate. Maybe each one will have each one will work as a robot system. And you want to communicate some others, friends or some other robots like that. This is known as a cooperative. And maybe that many of the tasks we do in our daily life in a cooperative way. And if you see that how the basically the ant systems, they carry the food particles from one location to the another locations. There is one food particles grapes is there, and so many ants are around these particles and they are moving in a coordinated way. All are moving in the same directions. Like each and every ant is different, but whenever they are moving simultaneously. Like, as a single entity, moving as a single entity is moving from one location to the another locations. And this is also true in case of micro robots also. So in case of like in the spy, okay, some sort of data collections or information collections, you can send so many robots in a battlefield near to the enemy side. They all will work together like, okay, coordinated. Like here, this is micro handling. Micro handling. Okay. Handling, if the big object size is quite big, you can handle it very easily. But when the size is very small, you want to pick up a particle which is of a nano size particle. How you will do it? There is a particle which is of a micron size particle. How you will handle it? Can you pick up a one blood cell? If say there are so many blood cells are here, can you pick up one blood cell? Can you identify one blood cell and pick up a particular that blood cell? It's not possible. But the doctors request that there must be some kind of devices, gripping devices, which will pick up a white cell like. The doctor wants to pick up a white cell or the red cell. You can pick up. With that instrument or that devices, you will be able to pick up. And this is basically required for the those who do the examinations. Okay, pathology. The people, those who are involved in the pathology, sometimes they require that to test a particular cell, and it is very difficult to identify a particular cell. Even after identification of a particular cell, how the cell will be handled? That is the real challenge. And here also the engineers are working to develop this small devices which can handle micron level size objects. This is one system. And you can just see this particular figure, okay, and this figure is known as a compliant figure, okay. Those who are means mechanical side, you have heard about these different type of mechanisms, like a 4-bar mechanisms, okay, crank connecting rod mechanism, this mechanism, that mechanisms. Now there is another kind of systems are there which is known as the compliant systems, where if you give a very small movement, your output will be bigger. Output will be big. So you have to give an input and then only you can get an output. That we know. So if I give a small input, the output will be like this. If I give a small motion, the output will be a bigger motion. And this is possible with the help of some mechanisms. That mechanisms are known as a compliant systems or compliant mechanisms. Okay. I'm not going through this part. So this is the basically the application fields of micromechatronics, and their examples they are saying. Like a field is medical field, biomedical engineering field, industrial field, in the service field. Okay. We find the applications of microsurgery in inspection purposes, cell fusion purposes, optic hazards, okay, and then maintenance purpose, information electronics technology, micro functional materials, transportations purposes. Okay, so these are the different applications of micromechatronics field. I think it will be better that if I give you some video which shows you see that how there is a micro robots is there inside this pipe, okay, how it is propelling from one direction to the left hand, from the left hand side towards the right hand side, it is getting propelled. Technology part, I am not moving towards the technology part. Let's say for example the kind of fish. Artificial fish. It seems to be like a real fish. Right? Yeah. But these are small robots, the micro robots. Looks like a fish. So even if you want to capture some information from the sea level also, so you require a robot systems. So they fish, and you can control this robot from the surface. You can control it. It can go deep inside the sea, and it can pick up some sort of signals or some sort of sensory informations from there. The quality of the life under the sea level. Okay. So that kind of informations, if it is required, so this fish will be able to pick up these informations, and these are all known as a microfish. And these fish, they can actually you can see that this is propelling, this is moving. Okay, so this is moving. Now for the movement purposes, there is some sort of composites, IPMCs materials. Okay, so these IPMC materials, it can be excited. It can be given some sort of excitations. It can give you some sort of electrical signal. You can give it to the material, and then the material will bend. A peculiar kind. A material will change its property whenever you give some sort of electrical current or voltage. Okay, if you give it, the material will change its characteristics. Maybe the size, maybe the shape, maybe the positions. The other properties of the material will be changed. So by using this IPMC, you can see by using this IPMC, IPMC is acting as a propeller, as a propeller one, which you can control it. Okay, you can control it, and then this fish will move from one location to the another locations. Can bend, means you can have a controlled movement, bending motion. It's not like that because of the load it is bending, because of the electrical power given into this material, and that's why the material is getting bent or deformed. It is twisting. Like here you can see, this is the same material. Whenever you are giving some sort of electrical power, it is getting twisted. It is getting twisted. The material is getting twisted. Basically, a sheet metal is getting twisted. Looks like a sheet metal is getting twisted. Segment type. Let me check it. This one. This is a. You can see that there are two IPMC sheets are there. Okay, and they are used for gripping of small parts, small components. Like you can see that this is the blue one and the red one. Okay, so they are very small particles, like small one, and they wants when you wants to handle this one. How you will do the handle? Because in this case, the robot will not serve the purpose. Robot will not be able to, for example, 0.01 gram. So how to handle this kind of particles? So for that purpose, we have robots, microsystems you have to develop, and here you can see that. And then placing it in another locations. It is possible. So it is the IPMC sheet which is holding the small objects. Okay, hold it, and then if you release it, you can release it, and the object will fall. So at least you can see from this demonstration that how to hold the object, how to grip the object, and how to release the objects when the size of the object is so small. Generally in the engineering field, generally we are not given this kind of knowledge. We always give the knowledge that how to handle tons of load. Okay, tons and tons of load, how to handle it. But when the load is of the order of 0.001 gram, how to handle that one? That is basically it is not taught. Okay, but we have to think it, because everything is coming in the mini. The size is like this, and then one day will come when the size will be like this. Every feature will be there. Maybe then it looks like a matchbox, small matchbox. Every feature, everything will be inside it. So people are going into the miniaturizations. And one of the advantages of the miniaturization is its weight is less. Otherwise, always you have to carry a heavy weight object. The power requirement will also be less. Power is very important. Okay, we are consuming so much of power, battery power. How to reduce this power? The power can be reduced only when the weight of the systems is reduced. The requirement of the power will be reduced. So that's why each and every technology, we are trying to bring this technology into the miniaturized form. Small, smaller and smaller. Each and every day there is a demand. How to continue what?
Sir, depends on the rate.
Okay, I will just this first. We are putting the small objects in these IPMC strips, and now you see that the human is operating like this. Human operated is like this. Okay, and the gripper is closing it. So, performed by the human, and a machine is doing this operation, but under the control of the human. So, you are giving the instruction, close it, then this system will close. You are giving it, open it, then the instructions is executed, open it. Man-machine interface is a very vital one. Very vital. Each and every machine is having some sort of machine, each and every machine having some sort of control with the human. Ultimately, you have to make the machine first is human controlled, human directly controlled, and then there will be machines which is indirectly controlled by the human. Not directly, but indirectly. Indirectly in the sense that your directions will be coded in the form of computer programs. The machine will follow the computer program, and computer program is basically your instructions. You have written the code, you know that what code means what. This particular code is for what particular actions, you know it. So your instructions is basically it is executed by the machines. This is an 8-minute video. You just see this video. This is an interesting one. A human is walking on a treadmill and the graphics is following you. The way you are working, the graphics is also following your motions. Like, think how it is possible. And it is like an online. Somebody is working on a treadmill and you have a computer on the computer, you have a human skeleton and the skeleton is following your motions. How it is possible? If you are moving slow, the skeleton will move slow. If you are moving at a faster speed, the skeleton will also move at a faster speed. How it is possible? Is it running or not?
It's running.
Speed is increased. Increase further. Basically, this is known as an exoskeleton. Those who have some spinal cord injury problems, they cannot walk. Okay, even they have a leg, but they cannot move. So the point is that whether it is possible to make some sort of artificial robotic systems, which they will wear and they will walk or they will move. At least they will move. Okay, so they cannot move because of they do not have the power. Leg power is not there. Muscle power is not there in the leg side. So they cannot work. They are always wheelchair ridden. But is it possible to make some sort of devices which they will wear, and these devices are known as an exoskeleton devices, which they will wear it, and these devices will be controlled by you only. Controlled by you. So with your brain signal, you will control, basically you are controlling your movement. Like say for example, I start moving. This is basically my brain signals. The brain signal has given the necessary instructions to the leg muscles to move, and that's why I am moving. So similarly, people are now working that whether it is possible that artificially any mechanical device, electromechanical device, whether it is possible to control with your brain or not. So people are working in this direction. So people are capturing the brain signals. Okay. Now there are certain activities that there which already discovered by the scientists, that there are certain activities that there is like a motion. Okay, my hand movement, my body movement. It is all generated by some signals from the brain. It is generating a and these voltages are how to capture the EEG signals from the brain. Brain signal is known as an EEG signals. So how to capture the EEG signals from the brain and then process these signals, and then you can control them. Say for example, there is a robot and I found that the robot is following my movement. Now even I don't want to move my hand. Even I don't want to move my hand. So I will control the machines by my brain only. So I will just look at the machines and I will think that the machine is moving from this location to that locations. I just think it. If I properly think it, with the concentration, if I think it, then I will find that the robot is moving from that location to that locations. It's possible. People has already done it. Okay, so this is known as a machine controlled by the human brain, and this is known as a brain-machine coordinations. Man-machine interface. Now people are thinking in a higher sense, how we will control the movement of a machine. I think I discussed has been developed in our robotics laboratory, and in which directions people are area. And one of the area we found that this is microelectronics or micromechatronics or micro or the nanorobotics. People are finding more and more interest. Like means it is like a step by step, okay, move in the forward directions. Now, size means we are in a position to develop the macro size, any objects, but we are just testing ourselves that whether we are in a position to develop the same thing, only the size will be reduced. Like size will be reduced because the size has a lot of bad effects, like, and weight is almost zero, like, so gravity force is not at all important. There are some other forces of theirs which are basically not so important in case of a macro systems, but they becomes very prominent in case of a macro systems, like a surface tension force. It's not so important in case of a macro systems. But in case of a microsystems, the surface tension force plays a very dominant role in the mechanics part of these microsystems. The microsystems are mechanics, and here the force, the analysis of the microsystems, the engineering part of the microsystem is something different than the mechanics. That basically the engineering, okay, you can say that the engineering is quite different if you consider the macro systems and the microsystems. Everything is there, but maybe in some sort of different forms. So we illustrate force is macro, but electronics part, mechanical part, there is a quite difference between these two. Applications also, lot of new application fields are developing. And as an engineers, we have to think in the microsystems part, and we have to develop the requirement. Okay. Any questions from anyone?
Using system so small, beyond the imagination.
This is means that mentions that surface tension force,
Yes.
okay, viscous force, they will become very prominent. Very prominent. Maybe in different, some other in different form, they will be in a different form. Equations may be completely different. Intermolecular interactions. In case of a macro systems, we never think about these intermolecular interactions. Molecule interaction we never think of. We are bothered about the friction forces, like. Okay. But here in this case, friction force may be negligible, like, in case of a microsystems. So molecular force is only there may be a particles, there may be some objects where only a no nothing is. And then molecular means manipulations of the molecules. Many molecules are there, so positions to orient the molecules as per your requirement. You will be able to orient the position.
Your device.
May not be in India, but outside it has been already common. It has been tested in the patient body. Like, it has been already tested.
So, sir, we have shown this the man walking and it's actually the software. So that is in the ISG.
I
So it's basically kind of motion.
motion pictures means
Basically, you are putting some record of the markers and you're capturing them and you're feeding into some software where.
whenever the person is basically working, so at that time, if you have a before the setup, we have placed one camera. This is known as a Kinect camera. So the Kinect camera means it is a kind of dynamic camera. It's a it is for the gait analysis purposes, and it captures all the time. It is capturing the leg movements, like this movement, hand movement, that movement. It is doing, and instantaneously the software part, the coding part, it is finding the angles, like and then graphics. So and the graphics movement, because graphics software requires the joint movement. So the time it is information, joint data is filled, and it is showing that one time basically you in a number of links. Like, so one link moves in the forward direction, next moment the link moves in the back. Ultimately, it gives you the impression it is showing the movement of the human beings. If it is so fast, it's a fast systems. The computational power should be high. The system should have a very high. Then only it looks like a realistic. Otherwise, what will happen? Your graphics part is a slow. Then you will find that the person has moved the step in the forward direction, and your graphics is showing that the person has moved in the backward directions, like that. So if there is a lag.
So this is particular software. Is a commercial software or this is the coding part is done?
Coding part we have done it. Students has done it in MATLAB. Maybe I don't know exactly in which systems they have made it, but they have done it.
The models that you're showing, that is a commercial.
No, that is a commercial. That means it has a particular software name. I forgot about that name. It's a biomechanics commercial software. No, not Adams. Not Adams. Not Adams. There is another biomechanics software is there, and which is basically used for the gate purpose. Maybe anybody like maybe. I forgot about this name.
So one of the things in the miniature field there is a self-assembling room.
This is also not in that means we have developed some sort of software coding. Okay, that I have also some video, but I have to search it and find out where a structure when it's starting it may have one type of configurations. And when the structure when that systems complete its operations, it may have another type of structures. Maybe initially it will be like a straight line, so starting point. But at the end, you will find that this is in a circle. And these systems maybe, say for example, not smart material, it is like a module type. These systems are like that. It will start with the 4 modules, but when it ended to the work, it may have 2 modules connected, and the last 2 modules, they may be left in some other locations. Okay. So this means it started whenever it, say for example, it started with the 4 modules. Okay. And then it finds a pathway where it is difficult to enter with the 4 modules. So what the system will do, it will just cut off the 2 modules. Okay. It will cut off the 2 modules, and where the cutoff action will take place, at that location, these 2 modules will die. It will automatically lose its power, like it will die like at that location. With the rest 2 modules, it will move further. There are reconfigurable type. Reconfigurable type means with start with some configuration. Before the work, you start with some configuration. In between, you change your configurations depending upon the requirement. Depending on the, whether you will move in a straight line or you will make a turn lane, curve or turn lane. Start with small, move to some location where there are other 2 modules waiting for you, and then you add on these 2 modules. So you will now have 4 modules. With these 4 modules, you move. This is called as a reconfigurable type. Reconfigurable, as the name suggests, that means you can change configurations. Your requirement depending upon the application, okay, it's constant. When you start, the situation was something, and during the process, the situation has changed. So one has to change the configurations also.
I have one question.
Yes.
Your student one project you have demonstrated, that is not so forward kinematics or reverse kinematics like things. They are guided by some artificial intelligence,
Yeah.
right? In that artificial intelligence type, generally we know that there are programming for robot language, etc., separate programming. Yet here in the case that such programming is not being used.
No, that kind of structural programming is not being
Not being used. So how you are interfacing that artificial programming language or with the robot function, etc.
I don't know exactly because the student has made that one, but the basic concept is that initially they have made some sort of try run, like so they placed one robot here, okay, one object over here, and they move the joints. Okay, so first joint is moving like we call as a theta 1 moved by 40 degree, theta 2 moved by 30 degree, and then we found that it has reached to that particular locations, and then again we move to another locations. Again, this arm has moved theta 1 and theta 2, we have changed it, and we reach to that particular location. So all these locations, they are now stored in a table like, in a big table like. It's a database, it's a kind of database, it's a big database will be there. And then when some unknown object is placed at unknown location, the system will search that this unknown position, definitely we know the position, unless and until we know the position, we will not be able to move it. So when we know the position, it will try to match it with the table. And where almost it may not match 100%. Where it is approximately matched very near, so that particular table it will take it. So from the table it will take theta 1 is like this, theta 2 is like this, and this information will be passed on to the motor. So the motor will move and the robot will come to these locations. Because the kinematics, if you solve the kinematics, sometimes if it is a 2-link one, the kinematics is very easy. But when it is a multiple links that are involved, the kinematics becomes really complicated. The system is not that much of a sophisticated system. That means theoretically, you will find that the robot is coming to pick up. Then again you locate this object over here. After 10 minutes you will find that the robot is coming. So who will wait for the 10 minutes and the 5 minutes? Because in the industry, this each and every second is costly. We cannot waste our time over there. So we have to develop some systems which is artificially intelligent. So these are very simple examples that I have shown over here, where the AI technique is used for the robot positioning purposes. It may not be for this solving of this two-link kinematics is very easy to do it. Okay, but it is the examples that it indicates that you can also use AI technique. Okay, instead of your mathematics, purely mathematics based kinematics. Okay, don't use that one. Use some AI technique to solve the problems more easily. These are alternative ways.
Now I've been having a similar question.
Okay.
So just a minute. So I have a small query. The database that you are talking about, is it based on DH convention? There are bit convention that is given theta 1, theta 2, theta 3, and theta 1 and 2 and 3 like up to theta 6.
Yeah. No, we are not following that.
Achha.
DH parameter, if you think it in that way, that means you are going with the pure mathematics. No, we are not doing that. So what we are doing that we have to do some sort of trial experimentations initially. So initially we place the object in some location and we try to move the motor, means the robot in a teach pendant mode.
Teach pendant mode.
We moved it along with the teach pendant
In the
mode.
playback mode, it will be able to replicate.
Then from the teach pendant mode, we will be ultimately we will be finding out what is theta 1, theta 2 and theta 3, theta 4 was.
Trial and error.
It's a kind of trial.
Generative conventional convention is a little bit complicated.
Only if it is a two link, it's fine, manageable. But when the number of links is increasing, then it is really difficult. And if you have a more than 6 means 3 links type of system, then it becomes more and more complicated.
Okay, thank you, Professor Romnik, for this very informative and engaging lecture. So now I'd like to request our Dean of Engineering, Professor Tarun Kandiya, to present a small movie lecture.
Actually, Professor Bhomik these are production engineering department from the very early stage, that is from 2000. As far as the syllabus is concerned, question moderation is concerned, taking extra classes. So each and every aspect is from the very beginning associated with the HIT and particularly the
Because
mechanical.
I worked under Professor S.R. Dev, who was also the director of the institute at that time. And at that time, I was a student of Jadavpur University. I was working under him. So completed at that time, PhD completed, but generally he used to call us, okay, to all his students like that. And we stayed in this campus for a number of occasions. So I like this institute very much. Thank you. Thank you.
I'd like to thank Professor Dr. Subhashis Bhomik for giving us his time for this FDP. So it was wonderful to have him with us. Always it is a pleasure hearing his lectures on mechatronics, robotics and Industry 4.0. These are his main research areas. So he has a very beautiful lab. He has always requested us to send some of our students to have experience in his lab. Our researchers who are working in this field can contact him and visit his lab. It's a very good lab with the latest state-of-the-art facilities he is having in terms of robotics, mechatronics. Okay, some AI systems are also there. So his research areas have called for some excellence in this field. So we really thank Professor Bhumik for giving his time and enriching our faculty members in this FDP. I hope this FDP was very full and very informative. So we look forward for more of his presence in our department, which will not only encourage our faculty members but also our students to impart their domain knowledge. Thank you, sir, for your kind presence. Thank you.